Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us on the Space Nuts podcast. I can't believe it's episode 130. My name's Andrew Dunkley, your host, and joining me, astronomer at large, Fred Watson. Hello, Fred.
Hello, Andrew. 130. Gosh, that's not far off your age, is it?
Yeah. I guess I deserve that because I've had a few goes at you. If I'm 130...
Yeah, well, it makes me a lot older. All right, well, we might just not go there.
No, maybe not. We've got a few things to talk about today. A binary star collision / supernova, which seems to be getting a lot of attention in the media at the moment, and we'll talk about why. And a ghost galaxy has been discovered. We will explain what a ghost galaxy is and what this one is actually doing. It's nearby. Just look out your window. Well, maybe. And a couple of questions. One about studying medicine with a view to working in the space program. That's a great idea. Shoot high. Why not? And we've got another question about Oumuamua, the space doogie, and its change in trajectory and what that might have been caused by. But we'll get back to that later. Oh, and a lovely note, if I don't forget, I'll read it out. We've just got this beautiful note, Fred, which I think is worth sharing. But first, let's talk about this binary star collision that seems to have a lot of people talking at the moment.
Indeed. The good news is this thing's 8,000 light years away.
Well, that's handy.
It is handy. That means it's quite a distant, a long way away in our galaxy. It is in the constellation Norma. Norma is the square. It's a southern hemisphere constellation, so that means, of course, it can be observed from the southern hemisphere. But what it is a pair of stars which are relatively unusual. They're called Wolf-Rayet stars. And these are stars that they've been known for 100 years probably as being objects that are unusual. They've got an unusual spectrum. They are now identified as being very massive stars which are kind of at the end of their lives and therefore a supernova risk. And they probably, in the end, when they go off pop, they collapse and you get a neutron star, which is a star that's the size of a city but has the mass of the sun in it.
Yeah, I can't get my head around that one either.
No, they're we know they exist and they're fairly common actually. Or it could be a black hole, depending on how big the Wolf-Rayet phase of stellar evolution is. But what we've got here is, and this is an Australian discovery, it's fantastic news, and it utilises our new strategic partnership with the European Southern Observatory, because the telescopes of the very large telescope in Chile belonging to the European Southern Observatory, they've been used for these observations. What's unusual about this is that there are two Wolf-Rayet stars which are in orbit around each other. So it's a kind of binary Wolf-Rayet. That's, I think, a bit of a rarity. It's probable that many Wolf-Rayet stars are in a binary system, part of a partnership of two stars orbiting one another, because a large percentage of stars are in binaries. In that regard, our sun's quite unusual because it's just a single star. But normally when you've got a Wolf-Rayet binary, only one of the stars is a Wolf-Rayet, and there's something else with it. Although the problem is the Wolf-Rayet itself is so bright, it's probably hard to see the other one, and so you might not observe it.
Well, I think that was the initial problem. They didn't realise what they had here. And,
yes, that's right.
I think I read one article that suggested this should have actually been discovered a long time ago, but it was just really hard to see.
So that's right. So they had to basically use infrared observing to penetrate the dust, because this thing's surrounded by a cloud of dust. They're very dusty objects, are Wolf-Rayet stars, and there's a lot of complexity in the details of how this thing works and what it's actually doing. I might just tell you that it's been informally named Apep, because that's an Egyptian serpent deity. Mm-hmm. But basically it's a fairly warlike Egyptian serpent deity, so it's got fairly grim overtones. But it's been called that because there is a serpent-like trail of dust and indeed gas as well coming from this thing. Apep is actually emitting almost like a Catherine wheel of dust as it rotates, and the speeds at which this wind of dust is being emitted from the star is they're very high. They're in the region of 300 or 400 kilometers per second. These are winds that are the ones you don't want to get caught out in.
No.
I think there is also there is thought to be a third component of this star, this system as well. I can't actually remember exactly the details of which bits are which, but I think it is probably a triple star system rather than just a binary.
Oh, right.
So the complexity increases as you look in more and more detail. And rather than try and describe it, because this is a very visual story, especially with these serpent-like jets of dust that are, winds of dust that are blowing from this thing.
Yeah.
It's not that easy to describe. But the issue is these things are thought to be the precursors of something called gamma-ray bursts. And gamma-ray bursts were a puzzle for a long time. Once again, they're a bit like fast radio bursts.
Fast radio is.
But they are not in radio, in the radio spectrum. They're in the gamma-ray region of the spectrum. That's very high energy. It's shorter wavelength than X-rays. They were discovered actually back in the 1970s by satellites which were put into orbit, not for astronomy, but to monitor atmospheric nuclear tests. That they were, part of the test ban treaty. These satellites were put into orbit to keep an eye on the whole world, because you can detect from the gamma rays if a nuclear explosion goes off. So that's what these things were put into orbit for. And in fact, they didn't find any coming from the ground, but they found lots coming from the sky. These very short-lived bursts of gamma radiation, just a few seconds. They've now been followed up over a period of a long time. We now know a lot more about gamma-ray bursts than we did before. And one of the possible origins of these things is systems very like the APEP system or APEP system that we're talking about, this pair of Wolf-Rayet stars and its third companion. Perhaps the good news in this story is that gamma-ray bursts are thought to be brilliantly bright. I mean, they outshine almost the whole universe when you see them, but in gamma rays, that is.
Yeah.
But it's thought that that's because we are along the line of sight of a jet of radiation or what we call a collimated beam of radiation that's going in one particular direction. And so it looks very, very bright because you're right in the beam. It's like a torch beam. But in fact, in other directions, the energy released is much less. And the good news about this story is that from the studies that have been done, the pole of these stars which is, or the pole of, the north and south pole of either one of them, I think, is not pointing in our direction. And so if there is a gamma ray burst and it's the pole from which this is emitted, and that's the current thinking from the theoretical models, which absolutely amaze me, the way these theoretical astronomers manage to pick out the details of what's happening from the basic physics. So the emission of gamma rays would almost certainly not be in our direction.
What would happen if we were to sustain a direct hit from a gamma ray burst?
I think it would be pretty grim for well, not just humankind, but all life on Earth, because gamma rays are, of course, ionizing radiation. It's very dangerous radiation. And if you've got something only 8,000 light years away that's beaming gamma rays at you, I think you're in big trouble. And it doesn't do you much good being on the other side of the Earth, because it basically strips off the atmosphere. That's what happens. Mm-hmm. It loses the atmosphere for a start, and then it goes downhill from there.
But being 8,000 light years away, if it were to go gamma ray burst tomorrow, supernova, whatever.
Yep.
We wouldn't have to worry about it for a while, surely.
Well, it might have done it already, Andrew.
Yeah, well, that's the thing.
The gamma rays be on the way.
Well, it could have happened 7,999 years, 364 days ago.
In which case, we'll see it tomorrow.
Yeah.
Yeah. What I was going to say was
But it's going to miss us anyway, so that's all right.
Well, that's the good news, because the ones that we see, the ones that are detected by satellites, and there are several satellites that are specifically to detect gamma ray bursts rather than, looking for nuclear explosions and things. But the ones that have been detected are at distances measured in billions of light years, and yet they are still brilliant in the gamma ray spectrum. So imagine that translated into 8,000 light years away, and you get an idea of what kind of ferocity there might be.
And I suppose that's what's got people excited, because they're saying that this collision is imminent and may result in a supernova, and that would be a spectacular sight to see, but we just don't know when. And as you said, could have happened already, but because of the space-time situation, we won't see the light of that event until it gets here.
Exactly.
Which could be tomorrow, could be 8,000 years, could be 20,000, could be, who knows? We just don't know.
That's right. So when people say this thing is very unstable and can go off any time, that's within the next 100,000 years or so, probably. Yeah. Just because the cosmic events tend to be they unfold generally rather slowly. So even though it looks as though it's on the brink of going pop, the good news is it probably isn't on the brink in human terms. It's probably on the brink in astrophysical terms, but not necessarily human terms.
Although in documented human history, there have been a few sightings of events like this, but, you've got to be in the right time at the right time, more or less.
That's right, yeah. Yeah, that's right. Just one footnote to this is that there's a strong Australian component, as I mentioned, to this story. And in fact, the University of Sydney, and in particular Peter Tothill, who's somebody I know, has been very active in this research. I listened to a lovely talk by Peter about 2 weeks ago on a topic that was absolutely completely different from this. But he did seem excited about the fact that there was some big news coming out, and that's what this is.
Okay. Well, we'll watch and wait, and maybe we'll get to see it, but probably not. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated number 1 by Tech Radar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked, and a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity. Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, yeah, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Next up, Fred, we're going to get into the macabre, the supernatural, because astronomers have discovered a ghost galaxy and it's close by. What is a ghost galaxy?
a galaxy that's back from the dead, probably.
Yeah, well.
I don't know whether that describes this object. It rejoices in the name of Antlia II. Antlia is a southern hemisphere constellation. So once again, this is observing this has been the province of southern hemisphere telescopes, including our very own Anglo-Australian telescope at Siding Spring Mountain near Coonabarabran. So what we have here is a galaxy that is basically being dismembered by our Milky Way galaxy. So it's one of the retinue of what we call dwarf galaxies, which were formed with the Milky Way, probably 12 billion years ago. Probably the Milky Way had 100 or so of these dwarf galaxies in orbit around it, but most of them have been subsumed into the halo of the Milky Way. They've been kind of gobbled up. There are one or two still there. The Large and Small Magellanic Clouds are the most well-known. They're part of our galaxy's retinue, the Milky Way. And there are also smaller ones, a lot that were discovered sort of in the post-war period, because they're nowhere near as obvious as the Magellanic Clouds, which are easily visible to the naked eye in areas where there's no light pollution and no moonlight. Times when there's no moonlight. But there are other ones which are only recognized by the fact that when you do big sky surveys, and this is the sort of thing I was involved with in the 70s and 80s with our UK United Kingdom Schmidt telescope at Siding Spring, because that telescope was a wide-angle camera, and you could look at the sky and basically pick out regions where the numbers of background stars were slightly enhanced, and then you can do follow-up astronomy to check what the sort of chemical composition of those stars at that enhanced level of population were, and several dwarf galaxies were discovered in that way. The most famous is the Sagittarius dwarf, which is, of course, in the constellation of Sagittarius. That means it's pretty well down into the depths of the galactic center. So that's the way you do it. Usually it's by counting stars, basically. Now, we now have a new tool in this regard, which is much more effective than the old photographic imaging that we used to do on the UK Schmidt telescope, because it sees fainter objects and it sees the positions of stars much, much more accurately. And that is the Gaia spacecraft. So Gaia is what's called an astrometric spacecraft. It measures the positions of stars very accurately, and it actually looks at their spectra as well. So the rainbow spectra, so it can deduce their velocities fairly approximately. So in Gaia data, a team of astronomers, actually led by a scientist in Taiwan, but including other scientists too. They looked at the Gaia data and have discovered this object, Antlia 2, and it's very, very close to the disk of the Milky Way. So it's once again, the problem is the Milky Way itself, the disk of our galaxy, which we see through the thickness as the Milky Way, that's very, very rich in stars. In fact, for astronomers who study stars, it's almost not worth getting into it because there are so many stars there. The trick is to find the empty space between them. And so to find a dwarf galaxy very close to the plane of the Milky Way, as this one is quite an achievement because you've got to disentangle the stars belonging to the dwarf from the stars belonging to the Milky Way. And you can do that, actually, by looking at things like their colours and if you can, their spectra, the rainbow spectra that gives a fingerprint of probably where the things originated. So that there was an alert put out because of the Gaia discovery by this group of scientists, and in particular, they wanted to. They were looking for some pulsating stars, variable stars, which are called RR Lyraes. And I actually, 40 years ago, I was an expert in RR Lyrae stars because that's what I was observing. But the same kind of thing. The thing about RR Lyrae stars is that they have a fixed brightness. The brightness varies, but once you take that into account, looking at the period of them, in other words, how rapidly they vary, and it's of the order of 1 day, you get a kind of standard candle measurement from that. It's a technique that's been known for 100 years. So RR Lyraes are great because they give you a distance, but they also are always found in dwarf galaxies. And so the hunt for RR Lyraes was very successful. And then this object turned up as being a newly discovered dwarf galaxy with RR Lyraes in it. And it was scientists at the Anglo-Australian Telescope who did the follow-up observation to try and find the stars that would be classified as members of this dwarf galaxy. They found more than 100 red giant stars, which are part and parcel of the dwarf galaxy. So it's a successful story. And the end product is that there is this galaxy which is a very loose one in the sense that the stars they're not all compact. It's an aggregation of stars that spreads over a much bigger area of sky than you would expect for a dwarf galaxy. That's almost certainly because it's being pulled apart by the gravity of the Milky Way galaxy. It's about 130,000 light years away, but it's more or less in the direction of the Milky Way. So you're kind of looking over the top of the Milky Way. The center of the Milky Way galaxy is about 25,000 light years away. You're looking over the top of it to this dwarf galaxy in the background, and that's the reason why it's never been seen before, because it's hidden among the nearest stars of the Milky Way. But it's a great discovery. There is some mystery still in terms of how big this thing is, because as I said, its stars are very dispersed. It's very faint. The stars are dispersed over a wide area, and even notwithstanding the gravitational forces that it experiences because of our Milky Way, it's not clear why it's grown to cover such a big area. So that's research that will almost certainly continue to be done.
And of course this, as you said, is not an abnormal thing, big galaxies sort of sucking in smaller galaxies, and there's probably a few more, maybe even many more, that we haven't yet found for similar reasons. But we're going to, as you and I have discussed in the past, going to see a major merger between two galaxies in the distant future when we collide with Andromeda.
Indeed, in 3.5 billion years or so. Unfortunately, Gaia will probably have run out of steam by then, so the spacecraft will not be looking in that direction, sadly.
Yes, but it's a fascinating discovery, and one that has certainly already raised more questions than answers, but it's something to certainly look into. This is Space Nuts. Andrew Dunkley here, Fred Watson there.
0G, and I feel
Space Nuts.
Finally, Fred, we'll try and answer a couple of questions. We've been doing them in batches lately, so we're getting nowhere, but we're going to just keep going with them. We've got a question here from Nina Mabarez. Where do you think Nina's from with a name like Mabarez?
Well, I would have put it in a Latin American country, probably. But that's not what the answer is.
Nina's from Sweden. I'm studying medicine, says Nina, here in Sweden, and was thinking of what field I want to go into in the future. As I have an interest in space, I was thinking if there is there a way to combine doctor and astronomy. For example, for a space agency. If so, what would the difference actually be between a doctor working in a hospital versus a space doctor? I like that. Space doctor sounds like a superhero. And also, how does the medical field look in the astronomical field? Good question.
Yeah. It is. It's a great question, and there's some, interesting answers to it. Just combining medicine and astronomy perhaps in the most rudimentary way. I do remember back in the 1970s when the United Kingdom, and I worked then in those days for the Royal Observatory in Edinburgh, we opened a telescope on the big island of Hawaii at an altitude of 4,200 meters. It was called the United Kingdom Infrared Telescope. It's still going, usually known as UCURT. But when that program started, we actually had a doctor attached to the unit, to the United Kingdom Infrared Telescope unit, which was the group of people working in Hawaii. And that's because their daily routine involved this constant decompression as they went up to altitude.
Oh, yes, of course. Because that's like, 16,000 feet or something?
It's 14,000 feet, roughly.
There you go. Yeah. So that's putting you up there in the
stratosphere.
Yeah, it is
almost. That's right. So that medical practitioner, I think he spent a year with us working in Hawaii to study the effects of this change in altitude on people's health. And I do remember, we used to have to go through fairly rigorous medical tests before we actually were allowed to go and visit the telescopes in Hawaii, which was a kind of duty of care thing, I guess, by the Royal Observatory. But it was interesting. I do remember going to one of the hospitals in Edinburgh to get myself checked out before my first visit there, which was in 1979. But that's probably not quite the kind of thing that Nina's thinking of. The whole area of biology, of course, is now intertwined with astronomy because of astrobiology, and that gives you a bringing together of some of the various aspects of these different disciplines. Astrobiology being not so much the search for life beyond Earth, although that's part of it, but trying to understand how life originated and how the various geographical or atmospheric features that a planet might have might interact with life. So astrobiology is perhaps another area that somebody who's studying medicine might think of going into. But there is, exactly as Nina suggests, there is a discipline of space medicine. And of course, NASA has a huge number of doctors who are very interested very interested in the health of astronauts at the International Space Station. This is all about looking at how spaceflight affects our health, how it might affect things in the long term with flights to Mars and things of that sort. So there is definitely a space medicine, science. It's probably not that easy to get into because I suspect it's very competitive. But I do know, because I know somebody who's done this, it is possible to go and visit NASA on a short space medicine course. I think she went to the US it's some months ago now, but was there, I'm not sure for how long, something like a month, particularly for a space medicine course. So this is a person who is a doctor, actually with a specialism of her own. She's an anaesthetist, but she's already a doctor, a practicing medical specialist, but because she's interested in space too, she did this this course and found it extremely interesting and very stimulating. And of course, would be very keen to get into the field of space medicine as a practitioner, perhaps sometime down the track. So Nina is not, not asking a question that's out there completely. It's an entirely realistic possibility. And my advice would be to check out one of these courses and have a look.
Absolutely,
which
yes.
will be easy to find on the web.
Yes.
Yep.
And of course, doctors would be very busy and on ready alert all the time when there are missions in space and people in space. And we certainly saw that portrayed in the movie Apollo 13, where they were constantly connected to biological sensors, so their telemetry was being fed back to NASA so that they could keep an eye on the health of the astronauts. And I think one of them did actually get sick on that mission. And so it is a really great field to pursue. So we wish you well, Nina, and thank you so much for the question, and good luck. So to our next question. Hi, Fred and Andrew. Could the Oumuamua trajectory change having something to do with the Yarkovsky effect, or is it not possible due to the speed or rotation and trajectory? This is a question that's come about because of the news of this exo-asteroid that has recently been suggested that might have been a light sail from another intelligence, aliens, which I'm sad to say, Fred, has been picked up by so many people on social media that want to believe it, and now they're rejecting the people who are saying, well, it's actually garbage. Yeah. People will latch onto anything. So they're now starting to think there are really aliens sending light sails past us. It's been dubbed Oumuamua because, it's a pickpocket passing by type of thing. But you might want to explain the Yarkovsky effect that Clem is asking about.
Indeed, and it's this is a really interesting question. Clem's question is a very good one. Because, yes, assuming that Oumuamua is, as we believe it is, a cigar or baguette-shaped rock spinning with a...
Other things have shapes like that, Fred.
Yes, I know. As you keep insisting, that's right. It's spinning on its axis with a time of about 8 hours or something like that, if I remember rightly. So the Yarkovsky effect is to do with the way heat affects a spinning object, and it actually goes back to the turn of the last century. It was in fact, not an astronomer; it was a civil engineer who basically thought of this, and his name was Osipovich Yarkovsky. So what happens? Imagine a rock going through space, being heated on one side by sunlight, the sun's radiation. Mm-hmm. So that's fine. What happens is that, one side gets warm and the other's not. And that in itself would cause unequal heating. And it means that there would be infrared photons. In other words, heat is infrared, emitted from the side that's getting hot. And those photons have momentum, and what they do is they provide a slight acceleration to the object itself. So it pushes it slightly to one side. But rather counterintuitively, if it's rotating, you would think, oh, well, that evens it out. If it's rotating, one side's cold, the other side's warm, and it's all gradually basted as the thing rotates. But the Yarkovsky effect can still happen, because as it rotates, the side that's been in the sun is warmer as it goes around the back, around the side away from the sun. It's warmer than the other side, and so you've got this emission of these infrared photons in a particular direction, and that can still provide an acceleration. So even a rotating object can actually be subject to the Yarkovsky effect. The accelerations are incredibly small, but they are enough to change the orbit of something. And in fact, this effect has been suggested as being one way that you might divert an asteroid that is on a collision course with Earth. If you've got long enough, you might hope that you perhaps could enhance the Yarkovsky effect by painting it or something like that, so that the thermal properties change. That kind of thing's been suggested. In fact, actually, the the bottom line here is that the theory is fairly well established, and we know it does happen. There have been actually tests which have proved that the Yarkovsky effect does happen. There's a note here, actually, this is on the Wikipedia page for the Yarkovsky effect, but mentions that an asteroid called Golevka was observed for a long period, 12 years, with the Arecibo radio telescope, so its distance was known very accurately, and it was found to drift by 15 kilometers from its predicted position, which turned out to be a measured drift due to the Yarkovsky effect. And actually, you and I have talked about the OSIRIS-REx mission, which is going to an asteroid called Bennu. That satellite is also going to check out the effects of the Yarkovsky phenomenon on an asteroid whilst it's in orbit there. So that's part of what's being studied. The bottom line, though, is that we really don't know too much about the way it affects your average run-of-the-mill asteroid, and in particular, something that's shaped like whatever it is shaped like, Oumuamua, may indeed have Yarkovsky effect being active on it, and perhaps causing an acceleration that is shifting its orbit slightly. But it's just one of many possibilities, I think. But it is a very interesting question, and Clem's kind of on the money to ask that one. Full of admiration for the questions that we get asked on Space Nuts, because they tell us that we are speaking to a very erudite audience.
Indeed, and thank you, Clem. That's been a ripper. One more thing before we finish up today, Fred. We got this lovely note from John Townsend, and he just wanted to give us some feedback. On the 21st of October, I introduced my 12-year-old grandson, Joel, to Space Nuts. Tonight, he sent me a text saying he had listened to all 128 episodes. You sure have fired up his enthusiasm for all things astronomical. So I'm very pleased to hear that, John. Thank you for telling us. We just love hearing stories like that. We've had a few over the last couple of years with a fellow wanting to buy his son a telescope, and another lady getting in touch with us about her daughter who's become inspired to get into astronomy. So if we're doing that, then we're really chuffed about it and very pleased. So thanks for the feedback. We love to hear these stories, and good luck to your grandson. Who knows where he may go in years to come, John, and please send him our regards. And Fred, thank you again. We certainly appreciate your effort. It's been a lot of fun, as always.
Yeah, great fun, Andrew. And hopefully we won't be talking about Oumuamua next time.
No.
Or light sails or whatever.
Yeah. It'll burn itself out eventually, and something else will come along and get people going. That seems to be the trend. All right.
Thanks again.
Thanks, Fred. Fred Watson, astronomer at large. And from me, Andrew Dunkley, thank you for listening again. We'll catch you next time on Space Nuts.
Space Nuts.
You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Sites.com.